All right, let's talk about quadratics. Specifically, what is a quadratic function? What kind of a function is that? What does quadratic mean? Well, we already know about linear functions. Linear functions make a straight line, and they generally have an equation that looks something like mx plus b. So it's like 5x plus 9, or negative 2/3 x plus 4, or x minus 7, or something like that to make a linear function. But what if we took that y equals x minus 7 and made it into y equals x squared minus 7? Would it still be linear? How will this exponent affect the function? Let's find out. In order to make this a little bit simpler, let's just drop that minus 7 and let's just make a graph of y equals x squared. We're going to do that by making a table first. And I'm going to pick some x numbers and plug them in and see what y comes out to. Let's start with negative 3. Why would we start with negative 3? Because I said so. If you plug negative 3 in for x squared, and put that negative 3 right here and then square it, you would get negative 3 times negative 3, right? Negative 3 times negative 3 comes out to what? Oh, it comes out to positive 9, because a negative times a negative makes a positive. And if we do the same thing with the negative 2, oh yeah, by the way, there's a little dot, negative 3 comma 9. If we do the same thing with a negative 2, then a negative 2 times a negative 2 is a positive 4. And then if we do the same thing with a negative 1, negative 1 times negative 1 is positive 1. You can check these on a calculator if you want to. So I'll put a dot at negative 1 comma 1. It looks kind of linear, maybe? Let's try 0. Oh, well 0 times 0 is still 0, right? So, okay, now it's not looking so linear anymore. Now, after this dot, you'll definitely know it's not linear, because if we plug in 1, what's 1 times 1? Yep, 1. And if I put a dot at 1, 1, oh, interesting. How about 2? What's 2 times 2? 4. Okay. And if I do 3 times 3 for 3 squared, I get 9. Look what happened here. It made a symmetrical little thingy where if we connected all the dots, it's like a U shape of some kind. Interesting. Definitely not a linear function, is it? Okay. So we asked, what is a quadratic function? Well, this is a quadratic function, y equals x squared. And it's not the only quadratic function. A quadratic function would be any function with an x squared in it, because any function with an x squared in it is going to make this U-shaped, this curve, which we call a parabola. A parabola is a symmetrical U-shaped curve that happens when you graph a function with an x squared in it. So what is a quadratic function? A quadratic function has an x squared in it, and it forms a parabola. Now, the parabola that you get from a quadratic function could be facing upward U, or it could be a downward U facing thing. It could actually get scooted up or scooted down or scooted to the right or scooted to the left. And all of that just depends on, do you have y equals x squared, or do you have y equals 5x squared, or do you have y equals negative 2/3 x squared, or do you have y equals x squared minus 7? Or changing all of these different parts of the function might make it go right side up, upside down, left, right, scooting up, scooting down. So how do you know what a particular function is going to look like? Well, you have to graph it. But they're all going to have a parabola shape because they all have an x squared and they are all quadratic. Okay, let's say you wanted to graph y equals negative 2x squared plus 7. How do you do it? What do I do? Well, we're just going to do what we did before. We're going to make a table and plug some stuff in. So, if I plug, oh my goodness, I guess I'm just going to do the work for you really fast here. But in case you're wondering where I got those numbers, here's where those numbers came from. To get this negative 11, I plugged the negative 3 in for x squared, and I did negative 3, sorry I can't write today, negative 3 times negative 3. I got positive 9. Positive 9 times negative 2 is negative 18, and negative 18 plus 7 gives you negative 11. That's how I got that answer. And you can do that for each one of those numbers down the table. Watch what happens when you plot these points on the graph. It's going to go like this. Oh, this one is a downward facing parabola. And it didn't start at 0, 0 like the other one did. Okay, so what if you have to do a word problem? Like this word problem, where there's a stone being dropped from a tall bridge. Okay, so notice on this problem, it gives us an equation. It says the height of the stone will follow this equation. It will follow this rule. So rather than making you watch me do all the math, I just jotted down all of the math here. And if you want to check it out for yourself, you can. But the basic idea here, again, just so you're totally getting this, is to figure out what goes in this blank here. I figured out that when the time is 0, the height would be negative 16 times 0 squared plus 144, and then I did the math, and I got 144 as my answer, which kind of makes sense because what's negative 16 times 0 times 0? 0, and 0 plus 144 is 144. So, eventually, after doing all of that, I found out that after no time, the height was 144. Oh, that makes sense because it said the bridge is 144 feet tall, and if no time has passed, then it's still sitting at the top of the bridge. Once time is starting to pass, it's going to start falling. So after half a second, 0.5, it's at 140 feet high. That means it went down a little bit, which makes sense because it's falling from the bridge. After 1 second, it's at 128 feet. It's falling some more. After a second and a half, it's at 108 feet, and now it's starting to look kind of parabola-ish. And after 2 seconds, it's at 80, and you can see the curve starts to get steeper and steeper. After 2.5 seconds, it's at 44, and then after 3 seconds, when I plug 3 into this equation, I get negative 144 plus positive 144, which is 0, and that means that after 3 seconds, the height of that stone is 0 feet. Oh, that means it fell all the way down to the riverbed. So, how long did it take for the stone to reach the river? It took 3 seconds. That's when the height became 0. So you can use quadratics to solve real-life problems, and those real-life problems happen whenever you have an x squared, or in this case a t squared. This gives you what we call a quadratic function. So again, what is a quadratic function? A quadratic function is a function that has an x squared in it, not just an x, but an x squared. And when you graph it, it always makes what kind of a shape? It always forms a parabola. All right, that's all I got to say for you. I will see you next time.